Okay, so let us discuss another topic for computing deflection, slope, and deflections. Okay, so we have the conjugate beam method. Okay, so first ako sang basahon ang iyang mga description sa book, then I will give you a summary or a simplification na mas dali ninyo siya madumduman o mas dali po ninyo siya masabtan. Okay, so here it is stated that another method of computing slopes and deflection of beams is the conjugate beam method, which is developed by Otto Moore in 1868 and H. Miller-Breslau in 1865. So kamo nalay research kinsa si Otto Moore o si H. Miller-Breslau. So this method is more convenient than the moment area method. So more convenient daw siya sa area moment. This is based on the analogy between the relation of load, shear, bending moment, and M over EI, slope, and deflection. So makita ninyo nga naiunom ka unom ka mga factors. We have the load, the shear, the bending moment, M over EI, slope, and deflection. So kana sila tanan paris-paris later. So in this method, the M over EI diagram for the beam is applied as the load on a fictitious analogous beam. Then the shear and bending moment at any point on the fictitious beam will be equal to the slope and deflection respectively at the corresponding point on the original real beam. This fictitious beam is referred to as the conjugate beam. Okay, so natay duha ka type sa beam. Sa conjugate beam natay gitawag og real beam, naputay fictitious beam. Okay, so i-elaborate na to na niya. A conjugate beam corresponding to a real beam is fictitious beam of the same length as the real beam, but it is externally supported and internally connected such that if the conjugate beam is equal to the slope at the corresponding point on the real beam and bending moment at any point on the conjugate beam is equal to the deflection of the corresponding point on the real beam. Okay, so kung imo siyang basahon as paragraph, maglibog siya gamay, no? So ato siyang isa-isahon. So ingana na siya. Ato siyang i-illustrate. So nakay duha ka type sa sa beams. Nakay gitawag nga real beam na po kay gitawag nga fictitious. So from the word nga fictitious, meaning murag fictional ba, no? Fictional, so meaning dili real, no? Not real. Dili siya real nga beam, pero gibuhat siya para ma-portrait nato kung ang relationship sa moment sa load, sa slope, sa shear, and deflection sa moment. Okay, so the real beam and the fictitious beam. Sa real beam, makompute na to ang M over EI diagram, which is the moment diagram. Using conjugate beam method, ang kaning moment diagram ang himuon natong load. Mo atong ibutang as a load sa fictitious beam. So later i-elaborate na to unsa nang fictitious beam. Okay? Then, once nga makuha na nimo ang moment, kunya itungtong nimo siya or ibutang nimo siya sa fictitious beam as a load, the next thing is that the shear, makakuha na kag load, tungtong nimo sa fictitious beam, kuha nimo ang shear and moment. Diba? Makadraw makag-shear and moment ani. Or pwede ka mo direct into moment nga di na ka mo agig shear pero makuha nimo si shear like katong gibuhat nato sa area moment. Diretso ka sa moment nga katong dili conventional way in computing, in solving, nga di na ka mo agig shear, mag-fix lang ka at any ends. So makuha nimo directly ang moment. Then it is stated that the shear of the fictitious beam, no, gikan ka sa load, giload nimo ang moment, kuha kag shear and moment. I mean shear sa load ug moment sa load. So ang load nimo sa moment, ang shear is moment times distance, then ang imong moment is moment times square sa distance. So the shear here is equal to the slope of the real beam, and the moment is the deflection of the real beam. Okay? So, klaro ba? So, kani ang pinaka main concept niya. So, later, ato nang i-elaborate unsa ng fictitious beam. So, mo gini siya ang main nga concept. The moment diagram, ana ang flow niya. Or pwede ka direct diri ana. The moment diagram becomes the load of the fictitious beam. The load eventually makakuha kag shear and moment. The shear is the slope and the moment is the deflection. Okay? So sa fictitious beam, ato siyang i-elaborate. Nakabutang diri ang properties of a conjugate beam. So fictitious beam is also known as the conjugate beam. Mao nang giyon siya fictitious analogous, meaning same length lang siya, walay ma-change sa length. Okay, so diri nato basahon siya no, properties of conjugate beam. The actual beam and the conjugate beam will always have the same length. So that is for number 1. Number 2, the load on the conjugate beam is the M over EI diagram of the loads of the actual beam. Number 3, a simple end for the real beam remains a simple support for the conjugate beam. And a fixed end for the real beam becomes a free end on the conjugate beam, and conversely. So mayon ka conversely, kung free end pod ang real beam, mahimo siyang fix sa conjugate beam. So nga na pag-convert sa real to fictitious, no? Okay? An interior knife edge support of a continuous real beam becomes an unsupported hinge in the conjugate beam, and conversely. Okay, so kung mayon kag naka-internal hinge, mahimo siyang internal roller. Internal roller will become an internal hinge when mo nang pasabot sa conversely. Then number 6, the conjugate beam for a real beam, real cantilever beam, is the reverse cantilever. Statically determinate real becomes always have corresponding conjugate beams which are also statically determinate. So ma-remain ang pagka-statically determinate sa isa ka beam. So even if the real beam is statically indeterminate, the corresponding conjugate beam is unstable. So true gid ako gi-edit na ko sa book kay murag mali siya. Unya ato ra nang ma-realize, no. The slope at a given point of the real beam is equal to the shear and the corresponding point of the conjugate beam. The deflection at a given point of the real beam equals the bending moment. So mo naman itong i-discuss. Equals the bending moment in the corresponding point of the conjugate beam. So the point of zero shear in the conjugate beam corresponds to the point of zero slope in the real beam. So take note sa number 11. The point kuno kung asa ang zero nga shear in the conjugate beam correspond to the point of zero slope. So mayon ka og zero slope, diha nag-act ang zero slope. Diha nag-act ang maximum moment. Okay. So the maximum moment in the conjugate beam corresponds to the maximum deflection of the real beam, which occurs at the point of zero shear in the conjugate beam. So 11 and 12 are connected ra sila, no? Kung asa kuno si point of zero shear sa conjugate beam, mo na point of zero slope sa real beam, and that is also the maximum moment. Diba? Kung asa zero ang shear, dito maximum moment, and then dito pod ang maximum deflection. So maximum moment sa conjugate beam, mo pod ang maximum deflection sa real beam. Okay? So ato siyang i-summarize. This is the first nga summary. This one, the relationship. Then the next summary is that for number 1, always bear in mind na ang fix mahimong ang fixed end sa beam, sa real beam, mahimong free end, or let's say the fixed end mawala pag nahimo na siyang conjugate beam. Okay, so this is the real beam, yapon niya, real beam and the fictitious beam. Ang fix mawala, then maingon ka og conversely, and ato vice versa. Okay. So kung ang fix sa real beam mahimong free end, ang free end pod sa real beam mahimong fixed end. So mabali-bali ni muna sila. Mo na yung number 1. Number 2, ang simple support will remain. Support will remain. So meaning, pag simply supported imong real beam, it will still be a simple support in the fictitious beam. So walay changes basta simple support. Kung fix, ma-free. Ang free, ma-fix. Okay. For then last is ang internal hinge will become an internal roller sa conjugate beam or fictitious beam, and vice versa or conversely. Okay. So kana lang kanang tulo. Kani mao ra gid ni ang summary sa kataas-taas nga explanation sa conjugate beam method. Okay, I will recall the moment of the real beam will become the load, and then the moment is the deflection the shear of the load or of that beam, fictitious beam, will become the slope. Fictitious beam, so convert nimo ang real beam to fictitious, mo ni ang mga consideration. Kung fixed end ang imuhang real beam, it will become a free end. And a free end will, in a real beam, will also become a fixed end. So mabali-bali sila. Ang simple support will remain even if real ba siya or fictitious. Internal hinge will become an internal ruler, and an internal ruler will become an internal hinge. Okay? So, to better understand, no, we will have an example for that.